I think they didn't lose anything. I was just um, talking about what's going to happen. So, so that's how we're going to go, and then I think it's going to help. So we're going to work like that. We're going to use the data science process from data collection, data cleaning through to analysis. Then later, when we are very okay with those ones, then we delve into we dive rather into the world of machine learning. Where we will start with things like supervised learning. At the supervised learning, we're going to look at the two main types, the regression and then the classification. Then we move on to unsupervised learning and we cap everything up with um, deep learning. And I don't know if there is time, we will do something funky. If we finish early, we will pick one week and do something very nice, like how to create something like ChatGPT from scratch, something like that. We pick something, yeah, or maybe computer vision course where like something small on it, how to train computers to see something like that. Yeah. So that's it. I don't know. We are eight now. I want to wait for two more, then we just jump into it. But for now, if you have any question or if you have any suggestions, if you have any contributions, anything, just unmute yourself and then let me know. Or just raise your hand. I'll call you. Yeah. Um. So this is what I don't like it when you guys don't talk to me. So I have to be calling names, right? So Sandra, you said thanks, babe. You babe somebody. Sandra, unmute yourself. This one nobody is typing anything. Sandra, do you have any suggestions? Anything? Yeah. I hope Sandra can hear me. I know Sandra you can hear me. So don't pretend you can hear me. It's not going to work. No. So while you wait for Sandra, Rashad, hey Nana, Kufiadu say welcome. How are you doing? I didn't even see you. Um, Rashad, do you have any suggestions, contributions, and
Okay. I think uh, looking at the number of what's the name miss classes we are having, and since the rain is not stopping any moment, I mean anytime soon, and the nature of our ECG, I think we should find a way of complementing the miss class. Just like yesterday, you said you will be recording the video and then you will send it to us to at least watch it before today's. So if we at least devise a means of which we can pick up to the loss or miss class, I think it will be nicer.
yeah, that's a very brilliant contribution. I think I'm working on that, like I said before. So right now, this is what I am thinking of. I'm thinking of recording, classes, so that when we meet, we will just be doing something like a tutorial. But the actual class, you know, I'll just record. And one good thing is if I sit down to record, and if it's not teaching, maybe if the teaching video will maybe cover 1 hour 50 minutes, the recordings, the actual recordings will just be maybe 35 minutes because it's not like I'm going to maybe run or maybe fast track things, but it's solely teaching. So I think that one will really be better. So that when we meet like this, we've already watched the videos and we just discuss.
Yeah, I think so.
Okay. So um, yesterday's video we are watching. So
Oh, okay.
morning. Yeah.
Okay.
So thank you, Rashad. You can mute yourself now. Nana Kofi, had to say, do you have any um, contributions?
No,
Okay, that's fine. Thank you. And now more.
No, please.
Thank you. Jonathan.
okay. So, yesterday I was watching a video, but I forgot. I've forgotten like some of the things they say. But one thing I remember was, as a data scientist, there are two things that you do, like two main things. The first thing is you getting your data. So with getting your data, there are techniques that you will use, the data pre-processing and the rest. And then you do the data science on it. So like you said, supervised learning, or if you are doing supervised learning, you do the classification and then using the regression. But if you are doing unsupervised, there are also other techniques. So he stated that getting the data is really, really very, very important. Sometimes the data may be structured, sometimes it may not be so much structured, and sometimes it will be unstructured. So getting the data is also very, very important. And then working on the data to do whatever you want to do is also important. So yeah, that's all I would want to see.
That's
Yes.
nice. But I want to also add something to what you said. It is true. It is true that um, it is true that we work on getting the data and then doing the actual data science. When you work in actually a structured company, it's not the data scientist who is going to get the data. You don't think about that. That is the work of a data engineer, and then yours is you request the data. So everything is saved mostly in organized corporations. The data will be saved in a database. You would write your scripts to get the data, or you can tell the data engineer, "I want this particular data." He will get it to you. You do your analysis. Other times too, the data wouldn't be available at all. So maybe you may have to scrape the data from the web or maybe do some combinations, all those ones. So we would look more into that. But those ones are advanced level ones. I feel more like if I start introducing those things here, then most of us will get confused. So it's a process, you get it. So when we lay the foundations, we're actually going to, build on that. Yeah, actually, myself, I work on projects. I don't think I've ever worked on a project where I had a data very easy like that. I'm working on a current project with my boss, and then the data we'll be looking for doesn't exist. So what I'm building on right now, what I'm working on right now, I've been coding since morning, and it's all about writing some scripts, web scripts, to go to Apple Music, to go to what's the other one? Those who support Barca. What's their name? Spotify, and then Shazam to get some data on people and their demographics, their demographics, and then the kind of music they listen to, so that I will just put it together and then kind of fix use it to train my data, be building some customer centric um, large language model, something like ChatGPT, but more customer centric. And it is true, talking of data types and all those ones, it depends on the task. Traditional machine learning mostly deals with structured data, but in advanced world, we deal with JSONs, the unstructured data like JSONs and all those things. For example, if you're building an LLM, a large language model like ChatGPT, we don't use rows and columns data to train. We actually use it in the form of JSON, the dictionary in the dictionary center. So don't worry, we would. But the actual truth is, don't worry, we'll be there. But the actual truth is, about 95% of data science things, are done on structured data. You know, it is only very few. Even in practice, except these ChatGPT things we see, deep learning isn't really implemented as the normal regression, linear regressions, and then we call them symbolic AI, the first AI approach. Maybe one day I will send you guys an article I'll write on the history of AI, approaches of AI, the top-down approach, the bottom-up approach, and how AI revolutioned to where it is right now, deep learning, how it was modeled, transformers, and all those stuff. Um, so that is just that. And thank you for giving me, for bringing that up. We're working on that. It means that you are really following. Right, welcome. How are you doing?
Yeah, thank you very much. I'm doing well. I was outside, so I wanted to get inside before joining, but I have to join because I was almost getting late. So I'm now going inside.
Okay, you are Bonti. That's nice. So Rashad, yeah, Rashad. Yeah. Rashad wants to say something.
Um, yeah. Uh, what? What's the name? Is it Nanamwa?
No, it was
Yeah, I
Jonathan.
think he just. Okay, Jonathan, right? Okay, he said concerning the video he was talking about. Is it the video you said you will be recording and then send it to us, or it's a different research he made?
I
And if
think
yes, because I didn't get any notification, from your channel that you have uploaded any video there.
yeah, I didn't actually upload a video. I don't think he's talking about my video. But Jonathan,
Okay.
what do you think? You clarify on that. I think it's someone's video. Jonathan,
Oh yeah, it's a data science course, and then during the introductory lessons, these were some of the things he talked about. So when he asked anything that we have to see, I said, oh, then let me share what I learned. So yes.
that's very nice. I want to add this thing. Data science is or the AI world is actually evolving day in day out. I remember when I first entered into the data field, I learned data analysis. And by that time, 5 years ago, for you to survive as a data analyst, you only needed three key, skills. SQL, you needed SQL skills, you needed Excel skills, and then you needed um, data visualization. That is either W or Power BI. And it was good. People were using that. People just learned that and get money. People were earning as much as 1,000 US dollars a month and all those stuff. But right now, as I speak to you, most data analysis are done in programming, like Python. So most of the jobs are requiring people to either learn Python or R instead of learning Excel and then all those stuff. Even some data analysis rules require you to know some basic machine learning because you'll be doing some modelings for your imputations and all those, some basic modelings, not like a data scientist. And also for data scientists, before they needed people with PhD and masters, but now they will tell you PhD, masters, or bachelors. And if you have the required skills, it doesn't matter whether you have a PhD or whatever. They will pick you over the one who has PhD, because research has shown that people with lower degrees always perform better than people in the tech field than people with higher degrees. Why? Because degrees are just theoretical, especially MPhils and then PhD. They are just philosophy, degrees. They just PhD is more of why this. So PhD is more of you know actually implementing a skill or something like that. But it's actually why does this happen? This why does that happen? So always writing theses and all those dissertations and then the stuff. So the data world is evolving. I would advise all of us to always watch videos like Jonathan did, so that we will know what is happening. Now people, if you want to be a data scientist, you would need, even entry level, you would need some hardcore, Python programming skills. You would need some knowledge on supervised learning, and even deep learning now. Deep learning, some even, and then there are a lot of new jobs evolving. For example, AI research scientist. I work as an AI research scientist for someone who is a professor in North Dakota State University in the US. And then he's a research person, but I provide him with all the codes. So we're building this. I have to sit down, have meetings with him, tell me what you want. I just think about it and then come up with the codes, something like that. And you get paid very, very well. All you do is, you know, me mostly in the afternoons, I prefer, I always like learning new things. That is why I stress myself. Otherwise, you would, enjoy. I just work from my home. My setup is here. That's all I do. I'll be in my room. That's all. We have machine learning engineers. We have um, a lot of things like LLM engineers and all those stuff. Yeah, and you should be watching videos, and then read articles and all those things. Utilize LinkedIn when they post jobs. Go and search at the job section. You search for data scientists, maybe entry levels, and see the skills, the requirements, and ask yourself, what do I have, and all those things. I want to be, getting questions like this. Dude, hey, hey Muta, I actually saw this post and then it talked about this. What is this? What is that? Or maybe you search yourself. Then it will open your eyes to a lot of things than just coming here. I teach you how to import or do all those things. Data science is mostly of not just the code, but what is the rationale behind the code. And today we will know most of them. So that is my advice to all of us. Let's time is fast spent. Let's us delve deep in and just get started with what we want to do today. When I finish, if you have any question, you can ask me. Um, let me quickly. I hope all of us can see my screen. All of you can see my screen. I don't know why today. Maybe today I'm very tired. That's why I'm drinking water like that. So today we're going to start what um, we call EDA. EDA is actually exploratory data analysis, and then when we say you are exploring something, so let me actually create a new let me create a new cell here, and then so, exploratory data analysis, or the sometimes for short, that is a term you will see most, EDA. So just the abbreviation. So exploratory data analysis, as the name says, you are doing data analysis. When we say data analysis, you're actually applying statistical concepts on data to actually discover some insights. What is this? What is that? Why that? Why, what, how, and why? Knowing the what, whys, and then the hows of the data, extracting insights. And when we say you are exploring something, it's more like you are actually doing much more, in-depth analysis on it to get more knowledge. So I'm exploring more. They ask you, Charlie, vacation, this vacation, what's up? You be like, oh, Charlie, I want to explore more, so I want to travel. Like myself, I want to visit the north for the first time in my life. So the whole thing is I want to explore. You get it? I want to go to the north to explore new culture and all those things. So explore is just to get new things, to get to know new things you never knew. So exploratory data analysis, or EDA for short, is actually um, doing data analysis to discover what you never knew, or what you would have never known if you hadn't done that data analysis. So that is simple. It's a very basic and well and straight structured definition from my side. There will be some, I don't like using formal definitions because nobody, if you go for an interview, nobody wants you to give a formal definition of something. They want to see how you understand. Now, some of these things are very, today I developed a new approach. This is what we're going to learn. I actually have coded almost all the things for today, and but we're going to actually duplicate this and then start to. So this is what we're going to learn. I don't know whether it is plenty, but I'll make sure we finish everything before we go. So I have written the codes already. I'm going to explain, and then I would also rewrite them for you so that we can move fast. So first things first, I always like importing all my libraries, all the libraries that will be needed in the work in the first cell. That is my thing. You can do any way you want, but I always want to organize my stuff. So first, we are importing NumPy, and I'm very sure so one, the NumPy, Pandas, and Matplotlib, we are okay with them. We know what they use. So we are importing NumPy as NP for all our numerical computations, and we are importing Pandas as PD for all our data wrangling, and we are importing Matplotlib.pyplot as PLT for all our visualizations. That is the charts you see in there. Now the new neighbor here is called missing no or missing number. So missing no is actually a library we use to detect missing numbers in a data. So it is used to handle missing values rather, not numbers, missing values in a data. So when we have some missing values in the data, this library has some nice and powerful tools, in terms of functions and attributes and all those stuff to help us and methods, not functions, methods and attributes, and then a whole lot of things to help us do that. So it is actually used for missing values. So we're going to use that to handle our to check for missing values, and then I'm importing it as MSNO. That is my thing. You can import it as MS, you can import it as MNO or anything, but this is the standard one all of us use in the community. Now the next thing is I read my data. Once again, read underscore CSV because it's a CSV file. You can see .csv. So I read it, and then I don't have the data in the same folder as the notebook. So that is why you see I actually have all this here. So if I had the data in the same directory or the same folder. Directory is another name, technical name for folder. When we say directory, we mean folder, a folder. So um, if I have had my data sets and my notebook in the same folder, then I wouldn't have needed to bring. I wouldn't have needed to go to bring all this stuff, right? And then after importing the data successfully, I store it in a variable called data, and I just call the .head method to check the first 5 rows of it. And you can see this is not new to us. I think all of us are very okay to the COVID-19 data set. So this is actually a real data set I pulled from the Ghana Health Service, and it is real, very real. That is a real actual COVID-19 Ghana data set. So you can see that the first um, case was actually um, recorded on the 12th of March. That is 6 days after the Independence Day, 2020, and then 13th we had another, something like that. Now let's see the last day of the this thing. So let's use the. So if you want to see the last entries, what method we use the tail, right? Now we can see that. Okay, so I actually altered something here. That's why. Sorry about that. Let me try restart them so that um, coming. Let me restart the kernel so that restart and clear our speed here so that I don't confuse you guys. think that'll be better. So let me import. So we start from afresh here. So let me import this. Now let me import the data. Now I want to see the last date of recording, of Ghana recording COVID yeah, case or the COVID entries. And you can see that was November 27, 2020. That was our last. You could see that day the confirmed cases were 98, and then we had 97 recoveries, and then zero death, and then we had the cumulative confirmed cases was 51,667, and then the um, cumulative recovered was actually 50,547, and then the cumulative death were actually 323 with active cases. That is when the remaining people were there. That is if you subtract the um, cumulative, the recovered from the active, the confirmed cases, and then subtract this from that, then we're going to get. I think yeah, I don't know, but it can be. We will look more into that. Yeah, we would discover how they were calculated. But I just want you to see this is the last, day of recording COVID data, or yeah, COVID cases in Ghana, and that was 27th November 2020, and the first day was actually 12 March 2020. So just for you. Now, after knowing that, let's look at the shape of the. Let me clean this. If you want to look at the shape of the data, like we always do, we do data.shape, and we can see that we have always the first value is the observation, that's the rows, and then the last one is the columns, right? So I don't want to do it this way. I want to make it human readable. I think yesterday I was talking about this. So I'm using the print, and then I'm using, you can see a little f here, which says that, which means it's a formatted print. And then what formatted print is, it actually is that we want to beautify the print, statements. So we want to actually incorporate some, variables in there for dynamic, stuff and those things. So I'm saying that I want to print. So let me even implement it here for you to see. So if you want to use a formatted print, you do it just like a print, where you begin with F and then you bring your quotes. It can be double or single, it doesn't matter. So now if I do that, all I do is, you can see that this is a tuple, right? The dot shape is actually a tuple. And then this is the first value, this is the second value. So if I want the first value of a tuple, then it's actually index 0. So I'll just call the tuple name, then end with a square bracket and put the position there to actually get the value. So now I want to say that instead of just hard coding that, forgive me today, I'm very tired. That's why the data set has, instead of doing it this way, let's say the actual print would have been, a data set has 8 variables. I just hard code 8 variables. That is bracket features and 233 observations. And then if I run this, yes, I have it. But the only thing is, we don't want it to be like hard coded one. There is no problem with this one, all right. So we don't want to hard code the variable number in and then the number of observations to in, because if we change the data, we still want we still don't want to come and then be hard coding the thing or be hard changing be changing the thing. We want to kind of make some automation so that if we change something here, it reflects here, something like that. So to do that, I just bring F in here. Start with F. Mind you, the F is not in the quote. It should come before the quote. Now if I come here, I want to actually output the variables. That is the variable this thing in the tuple. Now if you remember, we have data.shape, which is a tuple. So if I want the first value, if I do 0, I'll get the first value. And if I do 1, I'm going to get the second value, right? But we know that the second value is actually the number of variables which we want. So instead of just hard coding it here as 8, I can copy this and then come and paste here. Now, if I do that, you see that it is actually in red, meaning that Python sees it to be um, just a text. But this is not text, it is actually something which is an operation happening in Python. So what we do is we have to wrap this thing, anything which is not a text, let's say a variable or any operations you want to include in the print statement, you have to wrap it with the curly brackets, and you can see that now it is highlighted as black, distinguishing it from the text which is actually in red. So the same way, if I come here, then I can actually instead of 1, I want the first item, which is the observations. Now when I run, I get everything. So the data set has 8 variables and then 2233 observations. That is what I did here. Now, if you want, let's look at the information about the data. And yesterday I was telling you how valuable this is. Now, if you have your data, like um, Jonathan was saying, you have to understand your data. That is the key, the first most important thing in data science. If you don't understand your data, you can never have a good work. So now let's take some time to explore, the features of the .info, method for the data. Now, the first thing here is actually the class. And you can see that it tells you the type of data it is, which is a data frame, the data type, which is a data frame, which is true because we have rows and columns. Like anything like this is a data frame, combination of rows and columns. Now you can see range index. So you can see it gives you the number of entries, that is a observations, number of rows. So it tells us that it has 233 entries, which is true because we saw it with the dot shape method. Now and then the index. Remember, Python is zero index programming language, meaning that the first item is always given index 0, and that is why it says that it has 233 entries here. But the first one is actually index 0. The last one is actually index 232, which is actually going to sum up to 233 entries. Now you can see data columns. It also gives you the total number of columns, telling you that we have total 8 columns in here. And then now it's going to give you all the columns and then information on each. So the first column is actually index 0 and it is called confirmed. Now you can see the non-null here, non-null count. What the non-null count does is that it counts the number of observations in that particular variable. So we know that the data has 233 observations. So we expect each of the numbers here to be up to 233. If it is less than that, it means that that particular variable is having some missing values. Some of the observations there are missing. So you have to look into that. Now there is no way the number here will be more than the number here. It doesn't make sense. It will never happen. If it happens, check your computer. Maybe you are not using a computer, you're using a calculator. Something like that. It's never going to happen. So put that one in mind. The only thing which is going to happen is actually the fact that the number would be lesser than the shape of the data, right? Because we can have some missing values. But in our case, we can see all of them are 233, meaning that all of them are up to date. That is very nice. Yeah, very, very nice. We are glad about that. And then we happy, yes, because we want up to date data, and that is what we have. So it's a good thing. Now, knowing that, let's come to now. I used the missing no variable library I actually imported here. I'm going to use it to visualize. Now we've seen here that all of them are 233. Now let's see, we want to visualize it. Always pictures tell nicer stories than numbers. So I I gave it an alias of I imported it as MSNO. So I want to plot a bar chart which will tell us the entries in every variable. So all I'll do is I will just do call the MSNO, just like when we want to use NumPy, we say NP dot whatever. Let's say if you want to use the square root function from NumPy, you say NP dot sqrt. For the same thing, we want to use a bar, we want to plot a bar chart from the MSNO library. So MSNO dot bar, now it's a method, so we end with parentheses. Now we just put, we want to plot all the data, for all the variables. So we just put the data frame name in there, which in our case we call it data. Now if I run, actually my computer is slowing down, right? Okay, now it's in. So you can see we have some nice backgrounds. Now let's take our time to understand this. You can see in the x-axis, we actually have we actually have um, we have the variables. So we have the confirmed, recovered, def, those ones we see in there. Now when you come here this side you can see we have some decimals 0.0, 0.2, 0.4, 0.6, 0.8 and then 1. So it's more like proportions, or if you multiply it by 100 you say percentage. So when you come here to, you can see some numbers. So 46, it's just like scale. So you can see the maximum is 233, which is actually the the shape of the number of observations, the total number of observations, or the actual number of observations in the data. So what this is telling, and you can see some numbers on top of them. So we expect all the numbers to be 233, and then what this means is that it is telling us how many entries does each of the variables have. So if you pick confirmed, you can see that it has 233 observations and it sums up to 100%. So it is intact, and all of them, the bars are the same. You can see all of them are actually ending at the 1%, that is 1, which is 100%. And you can see their value here, which is 233. So it makes sense. It is telling us that all of them are intact. None of them is having missing value, which is very important. So that is what it means. Now, if you see, we have some output here, axis subplot, blah blah. If you don't want to see that, all you do is end everything with a semicolon. Sorry, a semicolon like this. And if you run this, if you run this, you should get, you see now nothing is there. So that is it. Normally I don't like that. So I like always ending it with a semicolon so that it suppresses the output for us. We call it suppressor. It suppresses the output we don't want and only gives us what we want here. It is very common in MATLAB, those of you who know MATLAB. Now let's come to the next thing. Now we after knowing the missing values and knowing that everything is all right, we want to perform some statistics. Remember, on last week, Sunday, we actually did, exactly a week today, we did something on statistics. We learned about mode, median, and now we know what they mean. So now we want to actually know, the statistics on these, on these variables. Yes. So to do that, we use the describe method in Python to do that. So you have to first call the data frame name, in which case we store our data, or our data is called data. So data dot, then we use describe. Now when we use describe, it's a method, always end it with parentheses. Now if we do that, you can see we have some table, very messy table, and I know some of you have started, crying. What is this? So now let's take our time to unpack this. You see, the columns are actually the columns of the column headers, the titles you see are actually the respective columns of our data. So you can see confirmed here, recovered dev, cumulative confirmed, recovered, cumulative dev, and then active cases. Now, so those are actually the respective columns we have in the data. And then down here you can see things like count mean, STD, mean, 25%, 50% max. So these are the statistics. Now let's take our time to unpack all that. Count is actually counting the number of observations in it. You can see that all of them have 233 observations. So all of them have 233 here. So if any of them would had had a missing value, it would have been the values for that particular variable would have been less than 233. Now we look at mean. Mean is the mean, the average. So it's actually calculates the mean for each of the um, variables. So for confirmed cases, the mean confirmed cases is actually 221.76, which is almost 222 because cases is a count. So let's round it to the highest integer, to the nearest integer, which is 222. So on average, what we mean is that on average, we expect to actually record or record or confirm 222 cases on average. That was so we kind of analyzing the COVID-19 data for Ghana. Now, when we finish, all of us will know whether it made sense, whether it was true or not. Whether what they were saying was actually true. Is it making sense, or actually they were scamming us? There's a new term in town called Cobra. It was the NSS people who made me know that. They say all the NSS people, the officials are Cobra. Small thing, no, they say you are Cobra. So we will see whether the Ghana Health Service was actually a Cobra, or what they were saying was actually meaningful. So that is up to us as data scientists to actually analyze the data to come up with that. So in the end, I'll ask all of you, tell me what you think about that. So back to what, if you're unable to tell me that, then all of you are Cobra. Anyone who is unable to tell me that, then you are Cobra. So back to what I was saying. So now we've known. So if you pick the recovered, we also have the average. On average, we expect 222 people to record 222 cases on average. We also expect to record to you know for we also expect for 217 people to also recover, and then we expected 1.38 death. That is, on average we expected one person to die. Yes, and then the cumulative um, confirmed cases was 28,000, you know, and then something like that. It goes like that. And then the active cases, we expected it on average to be increased by 200, 2244, yes, 2244, 2,244, something like that. Now, before I even move to the STD and the rest, now let me take some time to explain the variables to us. Now, the confirmed is actually standing for the confirmed cases, the cases we confirmed at that particular time, whether it was a day, a month. So you can see it was a date. So that day, the number of cases we confirmed, yeah. And then the recovered is the number of cases recovered on that, number of people who recovered on that day. Death is actually the number of people who died on that day. And then cumulative confirmed. Remember when we were in high school, we did something like cumulative frequencies. So if you have data and then today you kind of add them up, adding them up as the days or the time, increases, then we have cumulative. So the people in K University, cumulative weighted average, whilst you 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 keep going, you keep moving higher in your education as you spend more semesters, they kind of stack all your CWAs, your WAs, your weighted averages together. So we would add these terms, WA, your weighted average, on the previous ones, and then That is why they call it cumulative. It is more like stacking them on top of each other. Yeah. So when we, so it is more like, during the COVID time, they will tell you today that we had two new cases, and then making the total cases, you know, 2,000, blah, blah, blah. So that is adding all the cases from the first day to that day. That is a cumulative, confirmed. That is the confirmed cases. And the same thing for the recovery. That is the, cumulative recoveries we had. Then the cumulative death. That is it. And active cases is actually now when you subtract the, we have cumulative death. So when you subtract the recovered from the death, then the remainder will give you the active cases. The active cases is the people who are still there, who have not recovered, people who are not yet dead. So when you subtract the death and then the cumulative death from the cumulative death and then the cumulative recovered from the confirmed cumulative confirmed, then we have the remainder will be the confirmed, sorry, active cases. That is it. And I'm very sure now all of us understand it and we'll be on the same page. Now after knowing that, we're coming back to our statistical metrics. So our statistics. So STD is a short form of standard deviation. Now I think I explained to you what standard deviation is. We're actually looking at how we're saying that the average. So on average, daily on average, we expect to have 222 new cases on daily basis, and then we also expect 217 people to recover on a daily basis. We expect 1.39 is 1.4, almost 2, or let's say 4, one person to die on average, that is to die daily. And then now let me even not go here. Let's stick to these three. Now, how does that vary? Is it always going to be true? How does that vary? And how was so we have like kind of a straight line, which is the mean, which is going through. We want to see how these values, the actual values, were far away from the mean. So that is the standard deviation. We want to see the spread. How close did the actual value which happened that day, got close to our expectation. We expect 222 people to get new cases. Maybe today we had 50 people, so 50 active confirmed cases. So how far was today's um, confirmed cases from the expectation? The expectation or the mean is actually what we expect to achieve, something like that. Now, the standard deviation tells us. So if the standard deviation is bigger, then it is telling us that you know most of the values were very far away from the mean. So it is some cases. It means that some cases, some days had higher cases and some also had very low cases. That is why the mean is high, but on daily it wasn't really high like how we see it here. So like I was saying the last time, mean is subjective, to it's manipulated by outliers. So we always don't rely heavily on the mean when we have outliers. Yeah. So now that is the standard deviation. So you can see standard deviation of 241, and then we have 441. So although we have um, people who are actually, we have 217 people we expect 217 people to recover on daily basis, but this value can deviate off by 441, which means that the spread is very wide. So it can even be that nobody would even recover at all in a day. Although we, on average, per calculations, we actually expect 216. Now, if you have a value or if you perform statistics and you see that the the standard deviation is very wide, very, very large, even in some cases larger than the mean, then it is telling you that there are outliers. There are either extreme bigger values in there that caused the mean to do get to this value inflated like this, or actually there are some extreme low values which actually caused the mean to deviate like this. So that is one trick. If you want to detect outliers, always look at the standard deviation. If it is very, very big, then it tells you in most cases bigger than the mean, then it tells you there is an outlier or there is presence of outliers in there. So you can also look into that. Now mean is actually minimum. So the minimum number or the minimum observation in that particular variable. So the minimum case in a confirmed variable, the minimum number, which is going to be the minimum confirmed case, was actually 1. So it tells us that there was no day from um, what was the first day we even recovered? We recorded case. That was from 12th of March till 12 till 27th of November. There was no day Ghana didn't record a new case of COVID-19. So that is one thing you should take note of. So now we're not just performing statistics, but you can see we're making meaning out of the statistics we do. So minimum is telling us the minimum observation in that particular variable. And since it is one, and since this is a COVID data, and this variable is confirmed cases, then it is telling us that the minimum confirmed cases was 1, meaning that if the minimum confirmed cases was 1 and not 0, then it means that there was no single day in that COVID time that we didn't record uh, a new case. And then the least case we recovered was 1. Now, we recorded rather, not recovered, was 1. Now, when we come to recoveries, the least was 0. So it means that there were days where we actually never, we never had what do you call it? We never had people recover. It makes sense, right? And then the same thing, death, we have 0. It means that there were days where people, actually didn't die. Yes. And then the same thing for cumulative. The reason why I'm not actually going to talking more about the cumulative stuff is that they are just the same as these ones, the confirmed, recovered, and death. They are just like the cumulative ones. So when we talk about this, we are okay. But in the analysis, we would do them. But once we are talking about this, it's assuming we're talking about it's assumed or just like talking about these ones, they are safe. Now, when we look at the 25%, we call certain things quartiles. So when you divide the data into four, the first 25%, so what was the value at the first 25%? All these ones help us to actually detect outliers. Now, when we divide we cut the confirmed cases into four actual, what do you call it, four equal parts. Then the first one is actually going to be, the first quadrant is actually going to be um, 1 on 4. So 1 on 4 times 100 is going to be, 1 on 4 is 0.25 times 100 is 25%. So the first 25% of the data, so the value at the 25th percentile is 59. So it is later we will know much about that. And then the 25th percentile of, if you want to also read more, if you want to know more, just type percentiles in statistics and read more on that. It is very simple. So the 25th percentile for the recoveries was 32, and then therefore 0. And now the 50th percentile is actually going to be the median. For percentiles, we calculate percentiles by actually arranging the data, ordering the data, actually either in ascending or descending order, just like how we calculate the median. So now the one at the 25th percentage position is actually the 25th percentile. Now the 50th percentile is also going to be the same as the median, because it's going to be the middle number. So that is the median. So now the median is 131, and then the mean is what, 221. So you can see clearly median of 131, but the mean is what, 221. So it is very, very clear that there is an outlier. Always we call mean, median, mode as central tendencies. So we want them to be kind of closed. You know, they should be close to each other when there is no outliers. So if you have a data where the median is very far away from the mean, and the standard deviation is bigger than the mean and then the median, then there are outliers. Later we will know how outliers affect our data and everything. So the 75th percentile to is 295 for this, 221 for this. And then the maximum number or the maximum confirmed cases is actually the max is the maximum. That's so just like min is minimum. Max is the maximum, which is going to be the maximum observation in that particular variable. So we can say that the maximum number of or the maximum confirmed cases was actually 1513. The maximum recoveries Ghana had per day was 5,526, which is weird, right? This one, and then death, we had 15 deaths, at one, which is it's cool. Well, I'm not a health personnel. I don't know much about that. Maybe if any of you is health personnel, Zainab didn't come today. She would have maybe walked us through that. She's a pharmacy student. But for all I know, for all you know, is in the end, you would be able to tell whether it was a scam or not. So guys, so that's now we can see here that I actually added dot T, dot capital T. T is actually transpose. Transpose is just a term in maths we use to, it's like kind of flip something over. So you see, we have these ones here. Now we have the variables as the columns, and then we have the statistics as the rows. Now, if I want to turn them the other way around, for the columns to become the rows and the rows to become the column, I just do dot capital T. Dot T for transpose. And you can see now it changes. Now the cases, the variables are now the rows at the row level, and then the what do you call it? The statistics are actually the columns. Now, why I do this is that it is my own preference. I like it this way. And most times when you do and then it is very long, you transpose so that it's very nice. I like it this way so that if I pick confirmed, I can just read all its statistics horizontally. That way is easy than to go vertically. That's my choice, but it is good to know it will become handy later. So now I'm actually saving these statistics in a variable I'm going to call data statistics, and then later so that later we can use it. So that is it. So let me delete this one after knowing that. So now I'm now going to, you can see that this is a data frame. So I told you before, if you have a data frame and you want to actually select a particular column in it to output only that particular column and not all of them, all you do is you actually call the data frame name, so which is data in our case, end with square brackets. Then instead of unlike list where you provide a position, this one you provide a variable head. So for example, if I do confirmed, we would get the confirmed cases of our data sets. Now, this is actually also a data set. Anything rows and columns in this form is a data frame, so we can also use that on it. Now we stored it in data statistics. So we stored it in data statistics, and yeah, and if I want to maybe get the mean the same way, I just do mean, and you can see I get the mean. You can see that these are the mean. We have 221, which is 221 here. We get the 216, we get 216 here, just like that. So these guys, these guys are what is here. Now, what if I want to select more than one? All I do is then I have to provide them in a list. You know, so after this square bracket you see here is actually a necessity by Python. But if you want to supply you want to get one variable like this. But if you want to get more than one variable, then you have to provide the variable names also in a list. So first list, first square bracket, second square bracket. Then we can provide, I want the mean, I want the standard deviation. And if I do, you can see that I now have the two of them, only the two of them. So if it is three, you add the other one. For example, if I want the max, you can see I get it here. And that's how we do. So that's what I'm actually doing here. That's what I'm actually doing here. So I'm getting the mean, standard deviation, and the 50%. I told you that is the median. So I'm getting the mean standard deviation and then the median. Someone is saying, why don't we have mode? This is a numeric value, so we don't need mode for something. If we need mode, we will calculate. The mode is normally for categorical values, values which are not numbers. In this case, mode will not play any significant role. Here we need the mean and then the median and standard deviation. So I'm actually saving that in a variable called central tendencies. Now, um, you can see that the 50% is actually, let me uncomment, let me comment out this. And you can see we have it here. Now, I don't want this to be called 50%. It is actually the median. So I want to rename this, to median. So to do that, I can actually, to rename the variables or the columns of a data frame, I can actually use the dot, I'll call a data frame name and use the dot columns. Now, if you have a data frame name, a data frame like data, and you do dot columns, you don't end it with any parentheses because it's an attribute. And I run, I get all the columns, a list of all the columns of the data frame, sorry, which is here. So if I want to rename them, then I can actually call them and then rename them. So that is what we actually doing here. So I am saying that now I want to rename them. I am renaming the STD standard deviation and then the mean the same mean, the STD as standard deviation and then the 50% as median. So I am calling the central tendencies, which is actually this, you know, the data frame having the mean, standard deviation, and 50%. So if I call the columns and then I pass in a list of the new names I want to, in that order, you can see that here we have the mean standard deviation. You can see that the first is the mean, the second is the STD, that's the standard deviation, the third is the median. So let your name, the naming style, the order match exactly how it is. Otherwise, you wrongly name them. You won't run into error, but you wrongly name them. So now if I do this and I run, now you can see that the names have changed nicely. And I have mean, standard deviation, and median, which is nice. So now it is readable, understandable to all of us. Now I want to actually do some plots. I want to create some charts, nice charts. I want to visualize this. So I want to see the main, I want to visualize it. That's nice. So I'm actually going to use matplotlib. I plotted up, I imported up there. Now let's unpack this. First, let's take this guy here, and then I so I'm using the plt.py.plot. So the plt, I want to plot something. So plt stands for matplotlib. That's how we imported it. We imported matplotlib.pyplot as plt. So if you want to get anything from matplotlib, you call it. So plt dot now plot. Plot is a function or a method for plotting line graphs, lines. So I want to plot. Now you have to provide what you want to plot. The what do you want to plot actually? Now I want to plot the central tendencies. That is these ones here. I want to plot the means and then those things. I want to plot all of them. So central tendencies. Now if I run, you can see them. They are kind of weird, right? You cannot even see the columns well and those things. That's true. Because it's like the box is small, too small for it. So, and then we have these ones here. I don't like these ones. So let's take care of that one before um, we end with semicolon. You can see that one is no more there. But we we don't the columns are not good. So now how do we solve this? Now and then leaving the columns are some weird. So I am actually going to um, I'm actually going to create a bigger box where um I would plot them so that the columns will not squeeze like how kind of infusing into each other like we see here. So to do that, I am actually going to use a plt dot subplot. So the subplot. Now let me clean this first. So I'm actually going to use a plt dot subplots, which is the command we use to, or the function, sorry, the method we use to create the box, like the box you can see here. So now after doing that, if I run, I get the default one. You can see I get a box, right? A box. But now, if I want to specify the dimensions of the box, I always don't like the output space. So we have a nice box. This is a default one. I think it's 8 by 10 or something like that. So if we want to actually specify the dimensions we want, how big or how small we want, then we have to pass in what we call the parameter called fig size. So fig size for figure size. Then we do equal to, and we pass it through. Um, it is a tuple. It takes two things. It takes first the the length, that is, the length from here to here, the horizontal line, the horizontal length, and then the second value is the breadth or the width, that is the vertical distance. So let's say I want the length to be 10 centimeters, and then the breadth to be 6 centimeters. Now if I run this, you can see that the box is now bigger, and I have the length to be 10 centimeters. I don't know whether it is more than 10 centimeters or something. So let's say it's centimeters. Yeah, but it's centimeters actually, but your screen size, determines it. I have a bigger screen here, so it looks bigger. So you want, so I want 10 by 6. So this is 10 by 6. So the first value you pass in is for the length, and then the second one is for the width. You don't need to put this one in here. So if, for example, I didn't know and I did maybe 6 by 10, I'll get a standing rectangle. I'll be like, I don't want this. Then I'll know that, okay, it is the other way around. I just go and then do. So you don't need to always put things in your head, like always stack things in your head like how we do to write exams. No. So now after doing this, so if I do this, I'll get a big, place to plot them. That is nice, right? So now let me go and copy it and then come and plot. All I do is I have to to the next line. Python start from the first to the down, so we do that. Now you can see I added label equal to central tendencies dot column. So I'm actually telling Python that, what, let the x-axis labels to be the column, the respective columns we have in here. So the mean, instead of bringing me these ones, I want them to be mean, median, and then the mean, standard deviation, median. I want you to label them that. Later I will do um, a legend out of that. Now I plot this. Now let's see. It's still kind of infusing in each other, but we can see that it is quite better. So if I maybe change this to 12 and run it, you can see that now it's quite better. It's getting better. Let's see if we go by 13. It is getting more better. Now they are not stacking each other. Let's go by 15. That's nice. So you can see now we don't have, all of them are actually, kind of widely spaced, which is very nice. And then you can see we have confirmed recovery down here. Now, that is one thing. So when we pick, when we pick, when we pick, now we cannot see which one is for mean, which one is for standard deviation, which one is for median. So we can, and then we've not even labeled all the x-axis and y-axis. So we don't know what is the x-axis, what is the y-axis. So now to label x-axis in Python, we just use the plt dot x label. So plt, it's a function in matplotlib. That is why you see plt. Plt dot x label for x-axis, y label for y-axis. Then you put the name in quotes because it's a string in there. So Now let's go label the axis. So plt dot x label. Um, what did I even label it? Let me just copy. I entire to the page. Sorry about that. You'll be fine. Now when we do that, now we can see that we have variables features. So I named it variables. I think I didn't name variables or features. So you can see that these are the confirmed and those things. Now let's name the y-axis. So we're naming the y-axis as central tendency. Hmm. So we name the y-axis. Now we can see it's here. Now why am I naming it central tendency? It's more like a count, right? Mind you, understand your data and then always make sure you name the axis according to what they mean. So this is more like it's a central tendency or it's a frequency. Kinda what is the mean of this? What is the mode of this? Now let's kinda give it a nice title. So to give a title you do the plt dot title and then plt dot title. Now we give it a title and I'm giving the title to be plot of central tendencies. That is mean, median, and then standard deviation. If I run, you can see the title here, nicely done. And now it is making more meanings, but we don't know which one is actually mean, which one is mode, which one is not. So I do plt.legend, and then that's going to actually specify that. Tell me to let me know which one is the mid, which one is the median, which one is the standard deviation. If I run this, and we can see here. So the blue is the mean, the orange is the standard deviation, and then the green is the median. So this guy is doing that, and it is so because we gave labels. We pass the label, you know, um, arguments or parameter in here. So Python automatically detects and then tell us. It is saying that. So if I want to just, I don't even think, I have to think twice. I can just, okay, the green is the median. So now let's kind of understand this data, this chart, sorry. So it says that the confirmed cases, the mean confirmed cases is actually around slightly above 0, and then same thing for recovered and death. But when it comes to the cumulative, because they are kind of stacking, we stack them on top. You can see that the value jumps very high, and then same for all of them, all the cumulatives. So you can see that the cumulative depth, cumulative, yeah, the standard deviation for the cumulative stuff goes up, and then the mean also goes up, and the median is up. So it's actually very, very, very nice. Like it tells us, let us understand what's actually happening. So you can see that in at every point, the median is always higher than the mean, right? Which is a good thing. So the mean has some outliers. That is why it is kind of you know lower. So in this case, it will be good we use the median for analysis instead of the mean. Yeah. So that is what I did here. And then if you run this, that's the same thing you're going to get. The same thing you're going to get. Very, very nice. So let me just clean this. So we have this. Now data.index is actually going to give us. This is just not part, I think. Now I was preparing the notebook I did that. So now we actually going to plot. We're actually going to do more analysis. Now let's do more data analysis in here. So now we have um, the variables. We have confirmed, recovered, depth, and those things. So now let's plot them to see how they look like. Let's plot all of them one by one to see how their trends was like. And now we're going to plot the recovered. The recovered, we're going to plot it using a line plot. You can see I'm using a different technique. That is also there. This is actually built on top of pandas. So you don't need to do PLT or something. You just call the particular data. So it's more like when you have that particular data. So I want to plot the recovered. So I'll do dot recovered, and that is actually giving me the recoveries. So if I do dot plot, so I want line a line chart. I do dot plot. Dot plot is always for line chart, and I run. I'm going to get a line chart of it. So you can see very nice how it is. So that is what we do in there. But now, so you can see along the line, there were spikes, kind of like some of the values were down on, up and those things. So you can see when we got here, boom, spiked, up. Remember COVID time, we were there one day and 6 o'clock news, they told us around 14,000 people recovered. You remember that time? I think close to 7,000 or something like that. So that is that day. You can see that was the first day we had. I think they said 700. Forgotten there's a 5,000 something people actually, recovered, and it was a shock to all of us. It was a happy news, though, but it was a shock because how can you tell me the story, but well, that's it is what it is, right? So this is a visualization of how the recoveries, the people were recovering day in, day out. So you can see the line moving up and down, telling us the strengths and all those stuff, which is very nice, right? So we can see that the highest point was actually somewhere here. But now, what is wrong here? Now we can see that the x-axis is not actually it's supposed to be like something like a date, so that you can see that okay, this particular point is this day, this date, and all those things. But it doesn't do. But this one, the y-axis is actually the count, the value counts, the frequency, how many recoveries were done on that day. So to solve this x-axis problem, we need to um, actually um, encode, the actually pass the date as we tell Python we want the x-axis to be the date. We want the x-axis to be the date. So that is why I'm creating a new variable called x labels, meaning the x labels here, the labels of the x-axis. And then I am saying that it should be the date of the the data, our data, the date feature or the date variable in it. It should be that. And then what I'm doing is I'm using another method called xticks. So xticks is actually, when we say the ticks are these ones are the ticks. The ticks are the how we've ticked them. So when we say xticks, we're talking about how we tick the x-axis, how we mark them, the marks on them. So that is how if you use the xticks, you're referring to how the x is actually labeled. Now I'm saying that the ticks, that is the ticks you can see here, the marks, should actually be data.index. Now data.index in the sense that I want it to be the same as the data. It should cover the entire data so that it can run from here to here just like we've seen, nice. But I want the labels to be, the date, the date feature we have. Now, if I run this, let's wait patiently and see what happens. I think my machine is tired. It's been on since morning, coding, running a lot of big things. But it's fine. Now you can see we cannot even see the thing here. They are very packed together. Even if you open, you actually create a big box and you put them there. The dates we have 233 different dates. So we cannot put all of them, actually on the x-axis. They are stacking into each other. That is why you see this black this thing here. The words are overriding each other that they've created this black something. Now to solve this, why don't we just try do something different? Now something came into my head. I was like, okay, we have Let me do this thing. If you look at the date, the date feature or the date here, the date feature of our data, then let's look at let's do the third to. You can see that we have, let me output the first 15 features. Yeah. You can see that we have something like this. Now these are the dates, this is the format. We have the month, which is this is March, and then we have the day, and then we have the year. Now someone will ask me, how did I know this? If you come down here, you can see we have 17, 14, and 13. The months end at 12. We have 12 months. So this is obviously the day, and this is the month. So the format is month, day, year. Now, when you're dealing with it, you have to take care, make sure you understand that. Now, in this case, we verify that. So now, I'm saying that, okay, why don't we just split, kind of cut this date into three so that we have this one as a month, in as a feature in its particular column. And then we also have the days as another column, a separate column, and the years as a separate column. Now, to do that, we use the split, the split, let me give it that, the split method. So I want to actually split, how we split things. So I want to split the date feature in our data into three. So before we do that, we have to make sure we have to do .str. We can only split strings in Python. So we have to bring, always don't forget to bring .str before you bring the split. Now, if you do the split, it is a method, so we finish. Now you tell Python, what do you want to split on? I want to split the data based on the forward slash. So what Python will do is that it will come here, pick this one, split, because there is after this there is a forward slash here, and then after this one to pick this one and cut it into a different feature, and then when it gets here, it takes this one to and cut it. So we have three things now. So I'm splitting based on that. So the forward slash. And then if I run this, you can see now we have three things. So we have the month, we have the day, and then we have the year splitted into three. Now, if I want all of them to be in their in different columns, then I add parameter called expand. If I set expand to true, and Python is actually going to take all of them, put them in different, um, in respective columns for me. So you can see now they are in columns. So you can see column index 0 is actually the month, and then the days are also in one column, and then the year is also in another column, which is very nice. So knowing this, I can actually assign these, or I can actually add these ones to the data frame we have already, data set we have, the data frame. Now, if you want to add a particular variable to to the existing data set we have, which is a data frame, then what you do is, this is what we want to add. So we want to add them to the data frame. So we first have to specify, call the data frame name like this. And then in here, we specify the name we want to give to that particular column. So let's say, for example, I want to call it day. And then I come and say, assign it. So is equal to. So I'm saying that I'm creating a new variable in the data, in my data frame called data. And then it should be called day. And it should contain this value. But hey, we know that these values here, this split is actually three different values, right? Three different values and not just one. So we cannot do that. We have to pass three names so that it will name to give the names, because you cannot give store three things in one variable. It is three variables here, and we are providing only one variable. So when we do this, we will get an error. So we have to supply three, since we have three variables here, we have to supply three variable names also here. So that Python will create three different variables. So if you want to supply more than one name to a data frame, like I said before, you have to pass the names into a list. So we bring another listing, then let's say month and year, something like this. Then Python will see that okay, it will pick the first one and assign it to the first one here, the second one and assign it to the second one here, and the last one assign it to the last one here, something like that in the data frame. So now that is what's implemented here. So mind you, you can see that the format is very important. If you don't take care, the month comes first before the day. So that is why I am starting mine. I'm naming the first one as month, second one as day, and then year. And I split them. Now I split them. I run, I don't get any error. It runs perfectly for me, so everything is alright. Now I want to see them. So I want to see these three variables of of our data frame. So I call data frame name data. Then since I'm passing more than one name, I put the names in square in the form of a list, a square bracket. And I do dot head to see the first five variables, observations, sorry. And you can see these are them. Now, if I do now let's come and do the info to see whether they have missing values or not. You can see that they are all intact and the data types are actually objects. Why? Because Python sees them not to be numbers but objects. It is fine. If we want to change that later, we can change that. But for now, all I know is that we've successfully, added those, splitted the date column, and then now we have day, month, year in there, which is very perfect, right? So that is one thing. Now, if we go into our data and then now see, we can see that we have this is the date feature, and then we've created new variables out of the date feature, which are here. So we have the month added to it, we have the day, and then we have the year added to it. Now, if you create new variables out of existing variable in data science, we call it data or feature engineering. So you're actually engineering the feature or the data. That is the act of creating new variables out of the existing ones. So you can see that we've created new variable called month from the date variable here, day from the date variable, and then the same way year from the date variable. So we've done what we call feature engineering. So like I said, we'll be infusing them and we'll be learning them in project base so that you don't struggle with it. You understand it in the practical way, not the theoretical way. Yeah. And if you want to know more about feature engineering, head to the Google Classroom, download the feature engineering tutorial sheet. You would learn more there, or you can resort to YouTube or any the book I gave you or any of the listing you'll be fine. Now we have the day, month, year here. We wouldn't need the date feature, the date variable here because we have the day, month, year here. So now let's delete this variable from the data frame we have. So we don't want it again. So to delete this date or to delete a variable from the data frame, we first call the data frame. We call the data frame name, which is called data, which is data in our case. Then we add the method dot drop. The drop is actually a method, so dot drop. That is to drop something. We are going to drop what we don't want. Now the first parameter to give is a columns parameter, which is actually going to be the columns or the column you want to drop, you want to delete. Now, you want to delete the date variable. Now, mind you, put them in a list. Always put it in a list. If it is one, you can choose not to put it in a list. But to be on the safer side, just put it in a list always. So I provide date. And then I add in place is equal to true. Now, why do we say in place is equal to true? The in place is equal to true is actually going to take the data off at all, and then it's not going to add it that particular variable, sorry, off. So it's going to delete permanently. So in place equal to true will delete the thing permanently. But if you set it to false or if you don't provide it, it would tell you it has deleted. But if you rerun it again, you will see it there. But if you want to delete it permanently, if you want to take it out and take it out of the data permanently, you set in place is equal to true and then you run. Now that is what we have here. Now after deleting, I want to see how the data will look like. And you can see that now we don't have the, you see we had the date variable between the def and then the cumulative confirmed. And you can see that it's no more here, it is gone. That is nice. So that is how we delete a particular variable from a data frame. If we had wanted to delete more than one, then we would have just added the other one. Let's say, for example, we wanted to delete that, then we just add that one. But we don't want to delete F in this case. So that's why we just added. So if you wanted to delete two, you would have added the next listing in there. So now our data is ready. Let's do some data analysis. So we've done some cleanings, we've done some feature engineering, and then those things. Now let's do some analysis. Now we have the month, variable. Now I want to know the, confirmed cases by month, so that I will know which month actually had the highest number of confirmed cases, which makes sense, right? So I want to know the confirmed cases per month. So which month actually had the highest number of, confirmed cases. Now to do that, we use the group by method in Python. So we call the data frame and then you do dot group by method, and then you provide in the parentheses which variable or which feature do you want to group whatever you want to do by. So I want to group my output by month. I want to group confirmed cases by month. So I put what I want to group by um, in here. And then I then come and put the next one in a square bracket. So what do you want to group by according to months? I want to group the confirmed cases. And it is here confirmed. That is why I also put it here confirmed. Now, after knowing that, do you want to find the average of the confirmed cases or you want to find the sum? I want to sum all of them. So I want to know the sum of, the cases were originally um, recorded on daily basis. So I want to sum all the days of a particular month together and then put them represent the total as the the total confirmed cases for that month. So that is why I'm ending it with dot sum so that it sums that. So now if we run this, you can see beautiful. So we have March, which is 03. We had 161 um, cases, and then April, March, April, yeah. April had 1913. We had May 6,000, blah blah. So we can see that July had the highest. July had 19,678 confirmed cases, which was the point we all thought we were going to die. Yes, you and I thought we were going to die because when we listened to radio and heard all these ones were 19,000 people, everybody's heart was like, oh, what if what's happening? Like, am I going to die? People started wailing out this thing to people. You'll be there and someone won't even dash you money because they want to go to heaven. But unfortunately, I didn't get any money from anyone because I didn't know much. I was also hot. By that time, I was planning to move out of the country, and my flight was in some few months. I was very, very hot. Me, all my prayers was COVID should go and I go my abroad. But I never went. Here I am. So that's just a joke. So that's it. Now, after knowing this, I want to actually save it in a variable called confirmed month, just like that. And then when I output it, it's just the same as what is here. Just that we are saving it in a variable. Now let's try to plot it, represent it, plot it on a line graph. Now someone will ask me, why are you always using line graph, line graph? Now the truth is, if you have anything, any data which is kind of um, time bound, it is time bound in terms of it was recorded with respect to time. Either it is day, month, minute, hour. It is always good to represent it in the form of line chart so that we can see the trend from this time to this time. This was the trend. So that is what line charts are very useful for. Now I'm using, this is the variable I stored these guys in. So I'm using the dot plot to actually plot the, the line graph, and I'm labeling the axis. I said I want to label the y-axis as confirmed cases, and I want to label the title. I want to title it confirmed cases per month. And if I run this, boom, very nice. So we can see a very nice graph. Now, so you can see that March had the lowest because it was when it started hitting Ghana. Now the cases started going up, 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 up. So let's try to explain this. I think this is, pictures are always easy to understand. So from, before July, or let me put it like this, March recorded the lowest, cases, whereas July had the highest cases. Now also July had almost 20,000 cases, and then March was just around 161, right? So the other thing is we can see a trend from March to July. The cases were always increasing per month, month wise. And then after July, when we hit our peak, the cases started dropping. It started dropping to September, to even October, and then November it went slightly high. That was all. And Ado told us to take off our nose mask and all those ones, and we were free. Now we could walk. Lockdown wasn't there again and all this stuff. So this is a very nice thing, but I have a problem with it. Instead of, I don't want to see 0304, it confuses me sometimes. Instead of seeing 03, we all know 03 is for March. If we had March itself here, like the name of the month, it would have been better. So let's try to do that. Now, to do that, I know that I start from March, April, May, it start from March through to November. So I'm just creating a list in that order. So March, April, May, June, July through to November. And I'm calling it X labels. Now I'm going to plot the data. So I'm saying that on the X axis, I'm actually going to plot the unique values. So if you do the dot unique is actually going to give us the unique values in that particular variable. So that is how many unique values are there. So if I do data um, month, it's actually going to tell us how many unique months are in there. So you can see we have 0304 through to 011. So March through to November. So I'm saying that I want you to plot on the x-axis these guys there first. And then with the y-axis, I want you to plot the confirmed cases, the monthly confirmed cases. Now, I am passing this marker equal to 0. So what the marker actually does is that it is, or let me take them off first so that I don't confuse niggas, right? Nigga, take your time. If you don't understand it, it's fine. So now I want to plot on the x-axis. I want to plot these guys, the month, and then I want to plot the cases actually confirmed, the actual monthly confirmed cases on the y-axis, just like we see here, just like here. So confirmed cases here, and then the months on the x-axis. And then I want to just name the x-axis, and then the title, and then the y-axis. Now when I come here, I added something different. So the x-sticks, like we saw before, it's always anything which has to do with the x-axis. Now I'm saying that I want to replace these guys, that is the 0304, with the x labels. The x labels I have here. So that is with the actual names. So instead of 03, so it is actually going to go in order. So the first will match the first, The second will match the second. That's why we're using list. List has an order. So match will match with 03 and 04 will be represented by April, May for 05 through to November representing 11, which is the actual logic here. So if I run this now, when we can see that now um, we have the X labels are not 03 and these things, but actually the actual months, which is better, right? Now you can see rotation equal to 45 here. Now if I don't rotate, let's say I don't rotate, you will see what will happen. And if I don't rotate them, you can see that they are now the labels are horizontal and they are actually eating into each other. So instead of that, I want to rotate them 45 degrees so that they kind of incline themselves, kind of tilt, so that they don't go into, they are not horizontal and they don't go into. I can rotate it by 45 degrees and you can see they are kind of, so if I set it to 90 degrees too, it's going to be, straight this thing. I can set it to 270, 360, any value between 0 and 360. So I think 45 degrees is nice for this. Okay, so now let's get back to what we're here. There were some stuff here. Now you can see that this we don't actually see the points where, so the April, we don't see the April points. So the marker, argument here is actually going to specify, say marker is equal to 0. That is actually going to specify, kind of let us know where exactly the values are on the line. And then the line style is actually the style of line you want. Do you want a dotted line? Do you want, a straight line, full length line like what we have? Line width is actually to tell us the width of the line, how big the line should be. And I'm setting it to 3. It can be from 0 to any number. And the color is actually the color of the piece. You see, the default is blue. Now, if I want to change the color to the color I want, I'm saying the color is actually small g. G is for green. I can type green itself or just G. I can understand. So now, if I run this, oh, you can see now the color is green by the color equal to G. Line weight is, you can see the line is actually big now because I set it to 3. The default value is 1 if you don't provide it. And then the line style, I set it to dash. One dash means that it should be a continuous line like this. Now the marker is equal to actually 0. That is why you can see this circles at the point where are the actual data points. Now, if I change the marker from 0 to x, you would see some x, x's there. But I think 0 is nice, right? And if I change the line width also to dash dash, you will see now the line style will change to, the dotted. Is it dash or dotted? I don't know which is which. You know better. There is a lot you can explore if you if you type Matplotlib documentation. You can read a lot there. There is a lot of tutorials there and all those stuff. Now let me change this one to red. So I can type red like this, and I have this one, the color red. Or I can just do R, and I have it. Now let's say I want yellow and yellow. So let me see if I do Y to see it as yellow. Yeah. So you can give the first letter or the the full name and make sure you spell it right. Yeah, so that's it. So we've seen at least something nice about how to alter some of these things. There is a lot more to do. Like I said, you can actually go to the you can go to online and just type Matplotlib documentation. Click on the first link. It will take you there. There are some tutorials and all those things. When I finish, I'll show you that. Yeah. Now we're doing further analysis. Today analysis song Now let's look at um, recoveries also per month. So I'm actually saving it in a variable called recoveries per month. And I'm using a group by, I'm going to group the recoveries by month, and then I want to find the sum. So I want to sum all the recoveries in a particular in all the respective months together, and then represent it by that month. And if I print them, you can see that again, July had um, the highest number of, what do you call it, the highest number of cases, confirmed cases. It also has the highest recoveries. So when they gave us that big shock, they cooled us down with also some good news. So that is Ghana for you. Now we're just trying to plot that, but I want to plot using a bar graph. You can see at the plt.bar, which is going to be a bar graph, and I'm setting the color to red here. So I'm plotting the the months on the x-axis, and then the recoveries on the y-axis. And if I run, you have a very nice. And then before I'm creating the frame. I want it to be 10 by 6 so that it will be nice, to big enough to contain all of them. So you can see a very nice background, which is very reddish, like moja, right? Blood. So green, I like greens. If you're like me, fine. If you don't like any color you want, so green like this is also very nice. Let's see, orange. Sorry, so O is not understood. Let's see, orange, which is a very nice Ghana golden color. Yeah, let's see blue. Hmm. And let me take my orange. The green is what's happening. So green is also. Now I also want to see. Now we want so we've seen line charts, and now we've seen how to create bar graph. Now let's see how we can create pie charts. Now we can create. So I'm also creating a frame, 8 by 8 frame, just like we created a 10 by 6 or 10 by 8, 10 by 6. Yeah. So I'm also creating 8 by 8 frame, and then I'm creating a pie chart. So with the pie chart, we will do plt.pie, and then the pie chart we supply only the data we want to. Let me do it up here so that people don't beat me. So we do plt.py, and we supply the data we want. So we want to plot represent the recoveries per month, and if I get this dude here, pie chart, very nice. And let me suppress output so we can see only that, which is very nice. Now I want to give them labels. I don't just want to, because right now you can see which is which month and then those days. So we use the labels um, argument in the um, in the plt.py, and then I set it to the month. So the month is actually the name of the month is what I actually saved in the x labs labels. Now you can see how they are eating in, these ones are eating into each other, because this one is very thin. This particular month, the golden one is very, very thin. You can see July at the highest, followed by June and then August and the States. Now, what if I don't want them to be horizontal like this? I also want to rotate the labels a bit. Then I will say rotate labels, I'll set the rotate labels equal to true. So if I do that, rotate labels equal to true, then you can see that they are kind of rotated, they are not horizontal. Again, they are kind of tilted, very nice. And still, these ones are actually eating each other because um, that section is very small. Yeah, so that's how we create pie chart. So let's see, I did some decorations here, um, created a legend for it even here. So when we do plt.legend, we can actually get that. And then you can see the look is actually to tell Python where I want to put it. So I want to put it on the upper right. Now if I change this one to, let's say, upper left, let's see now it is on the upper left. Let's say I say lower left, see it comes down here. I think this one is nice. So something like that. So this is how it works. This is how it works. Very nice. Now someone is wondering, how did you get to know all these ones? Now it is simple. I'm not a magician, and I'm not the most brilliant person here. In fact, I am the laziest. I don't like um, get time. So if you want to know much about any of the plots or any of the functions methods, when you just call it, end it with a question mark, like I always do, run, and then you will get the documentation here. So you can see how we pass in there. So X, we put the X, and then we have explode, which all the ones which have equal to here, they have default value. So even if you don't bring them, the default values would come. So you can see even we have colors. You can you can pass in the colors you want. Now if you scroll down, you get um, they come to the parameters section. It explains all the parameters given here. So when you take the X, it says that so the X, that is a 1D array, like that is the wedge sizes. That is what you want to plot. And then when you see explode, if not none, blah, 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 it tells you about what labels and all this. So you read more about that. Or if you like, just go into Google, type um, plt.py documentation, or matplotlib pie chart documentation, matplotlib bar graph documentation, matplotlib line graph documentation. Click on the first link, you can read a lot there. So that is it. So you can see that's what I am actually doing here. And then the same way now, let's also look at depth per month. And then if you look at that, you can see um, August had the highest depth of 85, and then November had the lowest with 3. So now let's kind of visualize it with a plot, a line plot, and these are depth how it looks like. So you can see that the depth was kind of increasing um, till June, and then it dropped a little bit in July. It went a little bit up in August, where we had the highest ever, 85, and then it started dropping down all the way to November, which are the lowest, something like that. Now, let's try to plot recoveries. Now we trying to plot confirmed cases. I mean, all the three. Now we've seen confirmed cases. We've plotted it. We've plotted confirmed cases, deaths and the recoveries. In different what do you call it? In different frames. Now let's stack them. Plot all of them on one frame and see how they kind of look like. So to do that, I first create my dimension, which is a 10 by create the frame 10 by 6 plots, and then I first plot the confirmed cases, and you can see I'm giving label equal to confirmed cases. It is actually going to help us to add the legend so that we can see that this line color represents this line. So that is what the label is actually going to help us to. And then I plot the depth per month, and then I plot the recoveries per month. So all you do is just after creating the plot, just create all of them. Create this one. Just put all of them together. It will appear on the same listing, and I'm labeling them, and then I'm saying that I want a legend. Now you can see a new thing here, which is plt.grade. That is actually going to be like the grade lines, something like the lines here. So you can see now we have the boxes. So that is what the plt.grade is doing. I want to see the boxes, which is kind of nice. Yeah. So now we can see all the three put together. So we can see confirmed cases is it's actually the blue colored line, and then recoveries are actually the the green, and then death is the what do you call it, the orange one. Sorry, guys, my jaws are paining me. So it's fine. So we can see all of them together, and we will start, and we can see the legends here. So we can see the title, we can see very nice, we have very nice good. If I like, I can say, okay, I want to see, I want to make some markers so that I see some kind. So you can see we have the dots here. Maybe I would like to do the markers for all of them. That one will depend on you if you want to. It is good, everything, it's perfectly well. It is nice, so we can see if you want this, fine. If you want the access to, that is what you can do. So that's one thing. And then now let's plot the cumulative, stuff. So we plotting the cumulative confirmed um, by month. So if we find that and then we plot, we see this is how a cumulative distribution function looks like. It increases continuously to a particular point, then kind of become asymptotic to the line, something like that. Asymptotic means that it kind of become horizontal to it. Yeah. And then this is also for the depth. The reason why I'm not explaining this that much is that it's just like the same thing we did there, the same mechanism, just that it is different variables. So you can see this one too. You can label the axis yourself and then um, the recovered to review the recoveries. Now let's try to plot the three together, and this is how they look like. Very, very nice, which is very nice. So confirmed cases was always higher than recoveries in the cumulative way, but when we come in the on monthly basis, you could see that always in the beginning the confirmed cases. So from March to June, confirmed cases were actually higher than recoveries. So after June, recoveries was always higher than the confirmed cases. So we can say that okay, at a point we got vaccines and all those things. Doctors got to know much about COVID, and then they were able to cure it. That is why recoveries were actually quite higher than the um, the what do you call it? The confirmed cases. Yeah. And then you can see depth is almost like a horizontal line, not because it's horizontal, because the depths were actually smaller values. These were in 10,000s, the confirmed cases, and then the depth recoveries were in 10,000s. Depth, the highest one was just 89. That is why the line is kinda horizontal. But it's not a straight line because if you come here, you can see how it looks like. It varies, but the variation based on this scale is very minimal. That is why you see it like that. Yeah. So guys, that is what I want. This is what I wanted us to walk through. I'm very sure you've enjoyed yourself today, and I want to take some few questions from you on the course here. I'll drop this notebook in the class, what do you call it, in the WhatsApp group, so that all of you can have access to it. Yeah, and then also upload the video. So guys, that's it for today. Let me know your questions. If you have a question, just raise your hand and then I call you. Yeah, and I could hear this.
Thank you very much. It was a nice presentation. And I really loved it. It's just that it was there are a lot of technicalities in there. And I wanted to know with the format, the centers that you use, is there a way to shorten the centers? Or you would have to go by the normal method?
Which syntax, please? Is it these ones?
Yeah, let's the in 100. If you plot, I know that's the need. Those things, can you shorten them or that's the technical way of it so
Which
that we
one?
get the right answer?
I
I
don't
mean,
really
what you
get.
just highlighted,
Is it the
the
cumulative or
authority.
let's say the
I'm
whole of
trying to
this?
say, uh, let's say the whole of that. You see, there are a lot of
Um,
words in there, and is there a way to shorten them you're starting the analysis, or let's say when you're starting everything, is there a way to shorten it? Maybe you say cumulative confirmed is equal to this, this is equal to this,
Yeah, you can do
so
that.
that the name will be
But
shortened.
that's that's fine. But you cannot. This is a keyword. Label is a keyword, and it is optional. If you don't provide it, it's fine. If you take these ones out here and you run the code, it will run. You get it. But if you want to add
Okay,
more flesh to the bones, then you add more, things. It's more like if you want to give more sweetness to your soup, you add more ingredients. You get it.
okay,
Yeah,
thank you very much.
you're welcome, bro. So, any other question? Any other question? Okay, Bright, go ahead.
Yeah, hello. Please, can you hear me?
Mm-hmm.
Oh, okay. So, thank you very much for the presentation. Yeah, it was quite tedious. I was
I
trying
see.
to, get everything in detail, but later on, I have to pause and focus more on the explanation to the various codes that you've used to do the analysis. So I wanted to ask that, with the analysis, what at all are you trying to, get from the data? Because from the little I know, we are trying to, solve a problem. There's a question that maybe you want to use the data to get a solution out of it. So what are we doing at all? Because we take this variable, let's say confirm cases, we plot it against the months to see maybe which month has the highest number of confirmed cases. We take another variable and do it. But as we are going from one variable to another, we are not really, I don't know, like, I don't know. So I don't know if you can take me through what at all are we trying to get from all these things, or when you take a data set you have to do all these things for all the variables, and if not, then why do you have to do for some specific variables?
Okay. Thank you for that question. Now, the first thing I want to make it clear here is we're not working as data scientists. You get it? We actually learning. So these are some of the things you will do based on your project. If I show you some of the projects I'm working on, especially my LLM projects I'm working on, I would have to do analysis, and it will help me understand very well. Because mind you, the one who will give you this work does not understand the data. He will just give you the data, and you have to make some meanings from that. For example, during the COVID time, people were able to analyze the COVID patients, patients' data to know that people who are quite um, people who are quite old are affected more than people who are young. People who are in the colder regions are kind of affected more than people who are in the warmer regions and all those stuff. Now, let me just try to make one sense from um, maybe one of these charts. So I want to make just one sense from. So let's pick deaths. So you can see that if you look at this chart, the chart kind of from March, it keeps on increasing from March to April to May, then to June. After June, it starts to drop a bit in July, then it increases again in August, and it keeps dropping till November. And you can see the dropping was very sharp. Now, this is what I can draw from this. Let's say you were given this as a data scientist at Ghana Health Service. They want to know now there is COVID. COVID is gone, so post COVID analysis. They want to know how best we can tackle COVID. You can see that you can tell them that if I am the one, let me try to speak in my voice and see. So I would say that we can see that death was increasing from March to June, and I would say that that was just 4 months into the disaster. So people, we didn't have much knowledge about it. Doctors and experts were now learning. We didn't have much knowledge about what COVID was and then how to cure it. And we didn't have vaccines, we didn't have drugs. People were saying, is it oh, there is this um, I've forgotten the drug's name. It's some old drug, but they said when you take that drug, it cures this thing. That's what doctors are using to cure. Please hold on. Yeah. Sorry, someone just mentioned my name. I thought someone was at the door. Sorry. So I was saying that is it Amambi or hemoglobin? I don't know. Forgotten the name. Maybe if you remember, you can unmute yourself and tell me the name. They said the doctors were using that the old drug to cure COVID. So it's just by the way, but I want you to know, I want to just make some meaning from it. You could see that the deaths were increasing before July, which is because we didn't know much about that. But after July, the deaths started decreasing drastically because there were introduction of vaccines and all those stuff. So this is one meaning of this graph. If I come down to this one to the same way, you could see that here from before July, active cases, confirmed cases, sorry, were actually way higher than the recoveries. You can see that the gap between the green and then the blue point from here is wide, right? But after June, you get to realize the recovery starts um lie over the confirmed cases. What it means is that after June, more people started to recover. There were more recoveries than confirmed cases. Why? Because by that time people had had more knowledge about COVID. They knew that if you wear those masks, social distancing, washing your hands and all those stuff, it would prevent it. And then there were vaccines and then techniques of curing people. So that is it. So you as a data scientist, first that's why I was saying understand the data. And secondly, you should have some domain knowledge in wherever you're working in, and then you can make meanings from these graphs and all those stuff. But for now, we are learning as we learning something like raw, you know, this is your first introduction to something hardcore like this. That is why I'm not taking the explanation so much detail. From this one going on, we will start looking at how to interpret them and all those stuff. To get to your point, you'll be given a project in week 9 for you to, yeah, sorry. Yeah, I was thinking, okay. Charlie, sorry, people are scaring me here in my room. People are mentioning my name. Very, very sorry. Right, so I was saying, so this is kind of what it means. You look more into that, and I was talking about week 9. You'll be given a data like this. I won't say anything. I'll say do whatever you want to do with it. Do all your analysis and write a report on it for me. Make some meanings out of it. The truth is, nobody will ask you. Nobody, when you're a data scientist, your boss will not tell you, right, find this, and this. They'll give you the data. Normally, they don't even give you the data. They'll tell you, right, sales is very down this time. What is the cause? That's all. So it is up to you to know which kind of data you need, how to get it, and then how to analyze, and all these charts, how to make meanings out of them. I don't know whether I make myself clear now. Right.
Yeah, very much. Thank you.
You any other
Uh,
question? Or you
yeah,
have
I wanted
another?
to.
Okay.
Yes, please. I wanted to ask about the data cleaning. This data we are using for our practice is, I think, is already cleaned or is well structured. So I don't know if, because I know before we get to all these parts, we need to make sure the data is cleaned. So in the situation whereby we encounter with an unclean data or unstructured data, how are you going to go about it? Or you want us to maybe finish with this data before we get to the data cleaning aspect of this course?
You know, thank you for that. But let me say something. If I start things way up, you know, from just, bringing you, I bet you I can bring you dirty data, a very dirty one, that if all of you put your head together for maybe 1 year, you may not be able to get it cleaned in the way you want. I remember I worked on one project for someone, and it took me more than 1 month to clean the data I was given. Data cleaning is very very you know um, tedious something. So it forms about 80% of your work as a data scientist. Imagine I was working on this project, and then my personal project, and I have to query for, I have to write web scrapers to go to university sites to query the courses they do and then the descriptions and all those stuff. When they came, I had HTML tags and all those things. You sometimes you cannot even use Python alone to do. Sometimes I have to even go and use Excel to do some part, and then also come and use Python to do. Sometimes you even feel like I want to give up. Data cleaning necessarily doesn't necessarily mean doing something so much or something like that. It can be something simple. Even in this project, we've done some data cleaning. For example, if you look at, I'm going way up there, and then um, when we started the data, the when we started importing, just like you said, this is a cleaned data, so we didn't do much. So when we started, we have um, dates, and then we splitted we splitted it. So we even checked for missing values. That is part of the cleaning process. And then we there's where we splitted the data. Yes, this is feature engineering. And then now after splitting the data, we didn't need the date variable again, so we dropped it. So this is data cleaning. Now you are dropping or cleaning the unwanted part of the data. This is all data cleaning. These are some of the processes, but this is, like you said, this is kind of cleaned data. Don't worry, whilst we moving. If imagine I brought in with I just came in with a very dirty data and started doing all those transformations. I'm sure some of you will say, Charlie, me, I can't do this thing. I'll give up, something like that. So we're taking it one at a time. Yeah. So don't worry. It'll go over you, right? It'll go over you very soon. You will start. You will start to be like, hey, too much. So don't worry about that. Today, my Indian student, Deepika, she was like, I feel like I can't do data science. I was like, why? She said it's too hard for me. And I gave her some task, and then she couldn't do. So she told me, I feel like I want to give up. It's like, why? She said it's too hard for her. There are a lot of hard things, I bet you. Sometimes I stay, become very angry, like angry to myself because I can't do some of the things I want to do. Don't worry, we'll get there. I'm not scaring you. There are a lot of crazy stuff in there. You'll get there. Don't worry. Probably next 2 weeks, next 3 weeks. You have a first taste of it. And I'm going to write your name down, and you will be doing most of that. Yeah, since you asked, I'm sure you like it. Any other person? Any other question, rather? Namwa, go ahead. Namwa, you can go ahead. Namwa, was it a mistake?
Please, can you hear me?
Yeah, I can hear you now. Yes.
Please, I said the model for missing values is it Missino or what? I want to know the spelling right
Yeah,
because When I
Missing.
typed it, it was like they said there was no model for that library.
Yeah, so
So
you have to install it first. Whenever you import a model and they tell you there is no such model, and you check the name, and the name isn't there, it means it's not an inbuilt um, model or library. It's not a module, sorry, it's a library. Oh yeah, you can say a module. Yeah, it's a module because you import it in. It's a module, yeah. But whenever you do import a library and then it says no such thing from, you have to install it. It means it's not installed. To install it, simply do so you can do it install then the library name. So if it is, for example, the missing node, then you just do quick install missing. If you run, it will run. It will start some. You see some this thing. You see, I have requirement satisfied requirement because I have already installed it, so it won't come again. Yeah, that's how we do it. Now, are you cool?
yes, please. Thank you very much.
You're welcome. Any other question? Okay, so